Hi there, IB. I just want to go through some things in 5C, the horizontal and vertical translations. I just want to be able to move through this quickly. And they're just a lot of the key points we discussed in class today, but there's just some subtleties that I thought I'd go through that will help you move through this quicker in your homework. So the investigation, the initial equations we saw was in our vertical and horizontal translations that we have plus B, which is our vertical translation, and our A inside the brackets with the X is our horizontal translation. Key thing here is noticing the minus. This is set up as a minus sign, and we'll go into what that means. It's that whole thing of being opposite to what you think, opposite to what the Y does. If you work through the investigation, it takes you through various functions. We were graphing a cubic and then a quadratic and doing those translations. We found out overall that the A value, the one connected to the X inside the brackets, that's things like this 2 and the +1 and -5. This is our horizontal shift of A units. But if A is greater than 0, then we get our shift to the right. If A is less than 0, we get our shift to the left. And that's because it's set up as X minus A. So when A is positive, we get something like X minus 2 in this first example up here, which is our shift to the right. So if it's a -2, we get a shift to the right by 2 units. If our A value is negative, so it's A less than 0, so we get, in this case, X minus -1, which is the same as X plus 1, that's our shift to the left. So we can see in this first case, our A was equal to +2. Here, our A is equal to -1. So it's just watch that notation with the minus to indicate, to work out whether you're going right or left. So there are 2 graphs. So X -2 takes us to our right, shift to the right, and our X, this one here would have been Y equals X plus 1 squared, which is our shift to the left. The summary in the textbook goes through this. Plus B at the end. Y, B is greater than 0 moves upwards. Y is nice and normal. If the B is negative, it goes downwards. That's easy. For the A, that would be at the front one. Minus A, so A is positive, it moves to the right. A negative moves to the left. The shorthand way of writing this, when we have both translations done, so if we're doing a horizontal and a vertical shift, we can write it in what we call vector notation. So this is where we've got 2 terms. It's a bit like a coordinate point that's written vertically. The A, the number at the top, is our translation in the X direction, and the B at the bottom is our translation in the Y direction. So that means I can have a shift in the X direction of 3 and 4. If I write 3, 4 is our vector translation. Then it's talking about a +3, shift to the right, +4, shift vertically. So in this example, I've written down below our function here, our y was x squared. If it's been shifted by 3, 4, means we end up with y equal to a shift of 3 to the right in the x direction, makes it x minus 3 squared. +4 in the y, means the +4 comes on the outside. If I wanted to do a shift in the negative direction, then I need to have a negative inside the vector notation, and we'll have y equals x minus, in this case, -3 squared +4, and of course you can simplify that to x plus 3 squared plus 4. So you can go straight to that second step, but think of it as minus a minus 3. So the component or vector form, A is the movement in the x direction, B is the movement in the y direction. If I just want to think of one point, so here we've got a point on our y equals x squared. Oops, sorry, I put this down. I'll call it a point for some point P. It's there, is minus 3, 9. What will be its image after that translation? So we know that the minus 3, if we're doing our vector translation of, let's just do the 3, 4. So our x needs to move 3 directions to the right. So that means our new point was at minus 3. So if it's moved 3 units to the right, it's now at 0. It was minus 3 plus 3 equals 0. The y value is at 9, but it's moved up 4, so it's now at 13. So that's 9 plus the 4 gives us our 13. So we can just deal with it as a coordinate point. Does the order matter? Does it matter whether I do the x translation first and then the y, or the y and then the x? As you can see, they're not affecting each other, so no, the order doesn't matter. In your questions, there's some ones where we've got these interesting functions that are drawn. They don't have a set equation, they're called what we call a piecewise function, where we've got different sort of functions all put together. I'll just make a note of that term. These are piecewise functions. Just basically pieces of different functions. So I'm just going to do a different example from the textbook so you can get some practice. I'm going to do y is equal to the function of x plus 3 plus 1. In other words, I want to do a shift of minus 3 in the x direction and 1 in the positive direction. So if I think of that graph, I've just got it drawn down here. And that's not lined up, but I'll line it up in a moment. Okay, now it's like that. So this says I want to shift it 3 units to the left and up 1 unit. So each of these squares is 1 unit. 1, 2, 3. I want to come across here. Separating 3 units. And up 1 unit. So we're going to take it up 1 unit. So we could do, so we could do the whole thing, format just copy it. Let's see if I can just copy that and slide it across. Copy, paste. So I'm going to there, slide it across 3 and then up 1 unit. So that's where it's going to end up after it's shifted. We could do it just in coordinate points. So our key points here are minus 3, 1, 2, 3, minus 3, not lined up, minus 1, plus 1, and 1, 2, 3 here. Well, these points, I might try and realign the board. Okay, hopefully this will line up a bit better now. Okay, so our key points are minus 3, minus 1, 1 and 3. What are our y values? 1, 0, 1, 2, 3. This is at 4, minus 1, minus 1, and 1. Our first is we could do it in either order. We could do the x and then the y, or the y and then the x. But let's just go, the first one, we're going to go shift 3. If it's minus 3, we're going to the left. And in the next case, we're going to shift up 1 unit in the y direction. So our x values are all shifting across 3. So if it's minus 3, it's now going to go 3 units to the left. It will end up at minus 6, which is a bit off my scale. So minus 6, minus 1 ends up at minus 4, plus 1 ends up at minus 2, and 3 ends up at 0. The y's haven't been changed at this point. So they still stay the same when I did that first shift. Now when I shift it up 1 unit, all the y's are changing, but the x's are not. So these still say minus 4, minus 2, 0. But 4 now goes up to 5. Minus 1 goes to 0. Minus 1 goes to 0. 1 goes to 2. So we can think of it at a points, individual points level, using that function notation up here. Oops. Or we can get the whole graph and do the slide. The last one here in question A, I just wanted to point out that in this example where you're doing this transformation of minus 3 and then plus 2, find the images of the points on f of x. And in this case, find the points on fx which correspond to these points on gx. Find the images of the points. So these are your points on f of x. So you're starting off with 0, 0, and then you're doing a transformation on 3, 2 to come up with a point on g of x. So adding that, so the x goes to the right 3, and then the y goes up 2. In the second case, these are points that are either points on f of x which correspond to these points that are on g of x. So in this second case, so that's this one, this one here, these are the ones on g of x. So that's at 1, 6. How do I find the points back here on f of x? It's obviously undoing what the initial one did. So this first transformation shifted things to the right by 3. So the opposite of that means take them to the left 3. This was shifting them up 2 units in the y. So we now want to go down 2 units in the y. So that means our point, our x becomes at 1 on g of x, which means it must have been at minus 2 to start with on f of x. And so minus 2, if we do a shift of 3, it takes us over to the plus 1. Now we've got 6 on the y value of 6 on g of x. We want to go down 2, so that's at 4. So looking through our point here, if we do minus 2, add the 3, takes us to the plus 1. If we do plus 4, add the 2, takes us to the plus 6. So going from f of x to g of x, it's 3, 2. Going from g of x to f of x, it's minus 3, minus 2 to undo what was done. Anyway, I hope that makes things in 5C clearer. Thanks for listening. Bye for now.